And the sum of these two potentiating that result, and that gives us an estimated odds of 0.122. To translate that into is approximately equality or proportion 1%. So based on the results of this regression, we also estimate that the risk of respiratory failure in the gestational age equal to 34 weeks groups is much higher than that of the reference group. We knew that based on the odds ratio, but we didn't know what the actual proportions are. Here we see it's 11% for the group with gestational age of 34 weeks. Let's look at the breastfeeding status and child's age example and look at similar computations for this. resulting equation, we get the intercept odds of 4.6 and a proportion of 0.82 or 82%. So this gives us some more context by giving us a risk estimate for a single group here. We know that this group of 24-month-olds would have less likelihood of being breastfed than 12 months old and higher likelihood than 28-month-olds, for example. But this gives us a sense of the order of magnitude we're working with on the risk scale. I could certainly do the same calculus at different ages. So, for example, if I wanted to estimate the probability or risk of being breastfed among younger children, 16-month-old children, see how that compares the proportion in 24-month-old children. We know it'll be larger because these children are younger and the odds of breastfeeding decreases with increasing age, but we don't know by how much unless we do the computation, how much larger the estimated probability would be. So if we do this, each group will be exponential. Let's see, roughly 97% of children 16-month-olds are being estimated in this sample based on our logistic regression results. Since we've estimated both these probabilities at 24 months and 16 months, it's possible we could certainly go back and compute the relative odds of being breastfed at 24 months compared to 16 months, but we can also compute the relative risk because we now have these two risk estimates. We can take their ratio to get the risk ratio, the 82% who were breastfed at 24 months divided by the 97% among those who are 16 months old, and a relative risk of being breastfed at 0.85 or 80 of 0.85 for those two groups being compared. So those children 24 months old have 15% lesser risk of being breastfed than those children who are 16 months old on the two groups being compared. So those among those who are 16 months old, and a relative risk of being breastfed at 0.85 or 80 of 0.85 for those two groups being compared. So those children 24 months old have 15% lesser risk. Of being breastfed than those children who are 16 months old. on the relative scale. We could also do the risk difference. In this case, and as we've seen from the first term, and we'll continue to see, this is not necessarily always the case, but in this case, it's actually equal to a 15% reduction on the absolute scale as well. So this is a rare case where the results on the relative risk scale in terms of the reduction and the results on the risk difference scale are equivalent. 15% reduction on the relative risk scale, 15% absolute reduction on the risk difference scale. But this gives us two more ways of quantifying the result in addition to the odds ratio we would get by working with the results from logistic regression. If I were presenting this in a journal, I might present both the results of the logistic regression with the odds ratio and confidence interval for the per month change in breastfeeding in a graph like this, where you go ahead and use the computer to back compute the proportion or probability of being breastfed for each of the ages in the age range that we have in our data, just simply by recreating those computations we did for every age probability of being breastfed as a function of age. We certainly know that the odds ratio relating breastfeeding to age was such that the odds were decreasing with age, so that would result in a decreasing proportion or probability of being breastfed with age. And although on the log odds scale, the resulting function we estimated was a linear decrease on the log odds scale, when transformed back to the probability scale, we see clear evidence of this decrease, but it is not linear on the probability or proportion scale, because that's a double transformation of the original log odds scale. So this is helpful for giving context. We can now see the 12-month was odds segment. Like, let's present both the results of the logistic age and you creating the to age transfer percent, and then attenuate slowly until about 20 months when it begins to accelerate. By the time we're looking at 36-month-old, 3-year-olds, only about an estimated 20% are still being breastfed at that age. So in summary, for most types of studies, the only exception is case control studies, the results from logistic regression can be used to estimate risk, probability, proportion of the outcome for different values of the predictor, and hence we can get risk differences in relative risks above and beyond the odds and odds ratio estimates we can get initially from exponentiated results of the logistic regression equation. And the recipe is as follows. For specific values of x, 1, or if we have a multi-categorical value for. So in this section, we'll take on estimating risk and functions of risk data. There's some uncertainty, necessarily constrained or limited to only presenting results and computations on that scale. So just like we can get estimated proportions from this result, the estimated proportions of complex double transformation function of some linear combination of the intercept and the slope or multiple of the slope, we can get confidence intervals for these, but we'll defer with the computer. I wouldn't be able to do these by hand myself, even given the appropriate information, and I wouldn't expect you to be able to do so. But I want you to know that because these are estimates based on imperfect data, there's some uncertainty to them, and we could get confidence limits for these estimated proportions, and it would be a combination. It would involve uncertainty from both the intercept and the slope. intercept and the speculative proportion. Let's look at some additional exercises related to logistic regression. Outcome of response to antiretroviral therapy as a function of baseline CD4 count that was dichotomized. We did a regression that showed those who had lower baseline CD4 counts had higher log odds, and hence higher odds, and hence higher probability responding to treatment. And this comes from a logistic regression that says the log odds response is equal to negative 1.67, the intercept, plus 0.58 times x1. So 0.58 is the slope times x1, where x1 is a binary indicator, which is a 1 for baseline CD4 counts less than 250, and a 0 for subjects with counts at baseline, and 0 different log odds for two different groups of CD4 counts. The original coding was given by the following equation. Our intercept was negative 1.67, and our slope was 0.58. X1 was a 1 for those with lower CD4 counts. It's difference in the log odds for the group with lower CD4 count. It's coded 1 compared to the group coded 0 with CD4 counts greater than or equal to 250. With negative 1.67. This slope here is the difference in the log odds for the group with lower CD4 counts, coded 1, compared to the group coded 0, the group with higher CD4 counts. And subsequently, to get the log odds for the other group, the odds for the group coded 1 were those with CD4 counts of less than 250, we would take negative 1.67 and add that slope of 0.58 times 1, which is 0.58. And if we do the math for that, it equals negative 1.09. So now let's go and recast this. We want to refill. This slope here is still the difference in the log odds of response for the two CD4 count groups, but just in the opposite. Direction, whereas before it was the difference between those who were ones, those who were less than 250, compared to those who are greater than or equal to 250. This is just the difference in log odds in the opposite direction. So this slope will actually just be the negative of what it was before. So the log odds for before it was the difference between those who were ones, those who were less than 250, compared to those who are greater than or equal to 250, this is just the difference in log odds in the opposite direction. So this slope will actually just be the negative of what it was before. So the log odds, we've got a piece of this, equals some intercept plus negative 0.58 times x1 of the new coding. So what is the intercept going to be now under this new coding? This is going to represent the log odds for the when x equals 0, when our new x equals 0, for the group with CD4 counts of less than 250. But we already know from this operation over here that this log odds is negative 1.09. So we can put that in there. And what we've done is we've just times x1 of the new coding. So what is the intercept going to be now under this new coding? This is going to represent the log odds for the when x equals 0, when our new x equals 0, for the group with CD4 counts of less than 250. But we already know from this operation over here that this log odds is negative 1.09, so we can put that in there. And what we've done is we've just shown that we could estimate the intercept slope under a different type of coding, and the end result, the estimated log odds for the two groups we have will be the same regardless of how we coded it, but the intercept and slope will change value to reflect the result. The estimated log odds for the two groups we have will be the same regardless of how we coded it, but the intercept and slope will change value to reflect that we're changing the direction of comparison with our slope, etc. Just something else to note, here when we exponentiate this, the odds ratio we get, comparing the odds of response for the lower CD4 count to the higher was equal to 1.79. If we do it in the opposite direction, and we get the slope of negative 0.58, the odds ratio in the opposite direction is and odds ratio we get, comparing the odds of response for the lower CD4 count to the higher, was equal to 1.79. If we do it in the opposite direction, and we get the slope of negative 0.58, the odds ratio in the opposite direction is e to the negative 0.58, which equals 0.56. But just FYI, e to the negative 0.58 is equal to 1 over e to the 0.58, which is equal to 1 over the odds ratio in the opposite direction. So on the log odds scale, the slopes change sign. They're the opposite value of each other, but when we exponentiate to the odds and odds ratio scale, one odds ratio in one direction is the reciprocal of the corresponding odds ratio in the other direction. So let's look at the respiratory failure and gestational age example a little bit. one. So let's think about parse this for the group. at 0, the group of 7, the response, and over here, that this here will be is equal to the 1 on each side. Stational edge categories, ordinal